It's feasible.
Okay. So thank you. Uh, Myself Bishwajit Devnath, and I'll be speaking as mentioned, sustainable e-waste management for climate change. So first of all, I'll go through the content. So this is the contents of my presentation. I'll be covering these topics, minor and majorly. So let's start off with the electronic waste. So what is electronic waste? Any end-of-life electronic equipment that uses a power source or requires a power source for functioning is called the e-waste. So it could be a non-functional electronics, it could be a non-functional electrical, so it could be CDs, computers, televisions, phones, or it could be AC, refrigerator, coffee machines. So all these things are electronic waste when there is no functionality left. And in the West, they love to call it WEEE or waste electrical and electronic equipment. So both are basically the same. They're used synonymously. So if you look at the global statistics, in 2016, nearly 44.7 million metric tons of e-waste was generated. In fast forward to 2019, it was nearly 53.6 million metric tons of e-waste generated. And by 2030, it could be 74.7 million metric tons. And if we look at the BRICS nations, they contributed nearly 33% of the total e-waste generated. And India is one of the top 5 e-waste generators in the world, and it generated 3.23 million metric tons of e-waste in 2019. So that's the latest data. And if you look at the e-waste recycling market as well, it is also growing exponentially, and Asia Pacific region has the highest potential for the e-waste market. And post-COVID, things are also changing, but still the picture remains more or less the same. So why there is a huge amount of e-waste generated there? So briefly, we can blame the electronics industry. So this electronic industry is a multi-billion-dollar industry. So they are primarily driven by the demand, but again, the demand is also created by them. So what they are doing, they are using technological advancement, short innovation cycles, and intelligent business strategies, which actually is luring us to buy new and new products, and in return, the lifespan of the e-waste lifespan of the electronics are reducing. So as a result, there is a huge amount of e-waste generating, and it is exponentially increasing every year. So coming to the types of the e-waste, so there are different categorizations based on from where it is from. Like if it's from Europe, they have 10 categorizations. In India, we have 2 major sections, and in those major sections, we have 20 to 25 types of items. So whatever it is, it covers the all range of electronics, as I have mentioned, all range of electronics which has reached its it has covered its functional life, and even the solar panels that are becoming a waste today, those are also considered as electronic waste. Now, if you look at the composition, so earlier days, the computers used to be very heavy. Now it is becoming lighter. It's simply because the amount of metals are decreasing and the plastics are increasing. But the metals in the e-waste, that was nearly about 30 to 40%, depending on the, sometimes it goes up to 60%. So depending on the type of e-waste it is. So it was like that. The amount of metals was the main driving force behind the recycling of electronic waste. So now it is becoming a question that the sustainability, the business sustainability is becoming a question because of the increasing amount of plastics in the electronic waste. So the opportunities are huge, as I was telling. There's a lot of different types of metals present in the e-waste, and the copper price is slowly, it's skyrocketing since February, and right now I checked a few days back, it's nearly $10,000 per metric ton. So there's a big opportunity in e-waste. So that should be captured. But before that, we need to learn about the life cycle of the e-waste. So this is the life cycle of the mosquito. We all are familiar with that. We read it in our 5th or 6th standard. Similarly, we have the life cycle of e-waste with 5 phases. The phase 1 is basically the manufacturing and transportation phase. Phase 2 is the usage phase of the consumers. And from there, the phase 3, that is the UEEE. So UEEE stands for used electrical and electronic equipment. That means it is still functional, but it might not be serving my purpose. So that is UEEE. So that enters the phase, that's the phase 3. And the phase 4 is that if it can be repaired, so it is given a new life by refurbishing, and it is going back to the consumer through second-hand market. If it's not, it cannot be recycled, it's going to a recycler. So that's the phase 5, materials are recovered, and then at the top of it, I have shown it in dotted lines because that's where the loop is getting closed. And that's the major area of concern where still the researchers are working how to close the loop in a sustainable manner. So coming to the several aspects of e-waste management. So it is a very, very interdisciplinary area. So I have tried to sum it up in this diagram. So there are several aspects like supply chain management, information security, sustainability, policy aspect, cleaner production, urban mining, circular economy, intelligent and smart systems. So all these things are there. This is just a few. There are many more. So I'll be trying to cover a few of these, which are more important according to me. So first of all is the supply chain network or the supply chain management. So what is a supply chain network? It is a network between a company and its suppliers to produce and distribute a specific product to the final buyer. So it's basically the chain from the beginning of the manufacturing phase and coming to the market. So the chain that covers the whole work, that is a supply chain network. So, but for a waste management system, it starts after it is used. So after I dispose it, how it is going to the recycler, how it is being recycled. So that's the supply chain of a particular e-waste or a waste management system. So it is very, very complex. And how much complex it is. So if you look at my next slide, yeah. So this much complex is that. So the right hand, so any supply chain network has three sections. The supply section. So if you look at this section, this is primarily the manufacturing phase, and then from the consumer it comes to collection center. So this part is transportation and other stuff. So this is the supply side. Now this is the recycling or the internal operation side. So where the actual recycling is carried out. So that is the internal operation side. So here we have the informal recyclers, semi-informal recyclers who work with the trade rejects primarily. Formal recyclers are there, and then second-hand market. So that is basically our internal operations. And sorry, second-hand market is not in internal operations, the recycling part. So from second-hand recycler and other recovered products like metals, plastics, glass, and those are going back to the third-party recycler, from there to raw material supplier to the product manufacturer. So that's the demand part. So as I mentioned, it's very, very complex, and it is interesting as well. Now the second part is that's the urban mining. Urban mining is basically a new term which the objective is to recover resources from the urban waste and send them back into the supply chain. So urban e-waste is definitely an urban waste, and e-waste has a lot of metals and other materials available, as I have shown. So it is the most potential candidate for urban mining, and it is so that nowadays the term e-waste management has become synonymous with urban mining. So it is a very important thing, and it is a very important approach towards circular economy. As number one, it is helping in resource recovery, resource circulation, and resource conservation. So that brings us to the concept of circular economy. It is a pioneering system that creates a positive value socially, economically, and environmentally. So what circular economy does, if you can look at the picture on the right side, so the recycling actually helps to close the loop, which enhances the resource circulation. So in a way, circular economy in e-waste recycling system facilitates resource circulation and also supports the concept of urban mining. And let us look at a few e-waste recyclers who are famous worldwide. So Sims Recycling is there, Unicode, it's very, very famous, eParisara in India, Orbis in Germany, Wiser in UK, and then there are several more. So let me just show you, take a tour, give you a tour of what is actually happening in the field. So first, the informal sector. So what we do, TV is broken or something else is broken, we sell it to the informal sector, the kabaddi wallahs. So what they do this kind of stuff. They use very primitive and rudimentary technologies. I should not say them technologies. These are some methods actually they are implementing with very basic stuff, and they are trying to recover whatever they can and sell and make a living out of that. I don't blame them economically, but overall, this process is very, very hazardous and has enormous impact on the. And now the formal e-waste recyclers. So this is one of the e-waste recycler in India. So here manual dismantling is going on, and people are using proper protective gears, and there are also automated machines which are trying to recover metals and other stuff as much as possible. This one is in China, so they have sort of exhibited what can be recovered from refrigerator, trying to separate metals and non-metals through a running conveyor belt. So that's how things work there. So that's bring us to the major thing, that's sustainability. And why I am focusing on sustainability is simply because climate change is a subset of environment. So addressing climate change means I am also addressing sustainability. So what is this sustainability? is, according to the Brundtland Commission, meeting the needs of the person without compromising the ability of the future generation to meet their needs. So essentially, there are three pillars you have to address: the environment, economy, and society. But the boundaries are not explicitly defined. You can have your fourth pillar as well. For example, I have considered operational here. It could be anything, it could be demand, but it depends on the system itself. So coming to the climate change, and why there is so much, why serious about climate change? The numbers speak for itself. 35 plus million people getting affected by flood, 16,000 plus deaths with heat waves, and there are many other impacts of climate change. For example, foodstuffs and consumer goods, their prices are increasing, heats are increasing. In the coastal areas, in the coastal areas, the cost of adapting is increasing. So it is affecting in different ways, in socially, economically, environmentally, everywhere. It has a big impact in our life. So what is the function that connects electronic recycling? So we need to find the function, right? We are talking about electronics and then climate change all of a sudden. So what is the function? So this is how we are connecting the e-waste recycling with climate change. So first of all, recycling activity reduces greenhouse gas emissions, and using recycled materials to make new products reduces the need for virgin materials. So in return, it is actually reducing the need for virgin mining, and it is in return it is avoiding greenhouse gas emissions for extractions. For example, recycling, if you are making something out of aluminium and if you're using grain cans, so it consumes 95% less energy compared to virgin recycling. And another thing is that when we are recycling something, there is there's a good amount of that part is basically the metal, or basically the things we are recycling, and the impurities are quite less. But when you are doing it from the ore, the impurities are much more. So there where the cost is also a factor. So that is also another way that it helps. So coming to the next portion, urban mining. Urban mining increases the material availability as well, and it reduces the transportation. So it also has positive climate impact in terms of supply chain management as well. So recycling e-waste reduces methane emissions as well, and e-waste, what is not recycled, it contributes to about 4.25% of the greenhouse emissions worldwide. So in a nutshell, what I was trying to say is, if you look at this, is more like this part is more like the supply chain that I was shown, a very simplified version. So from virgin mining, metals are there, electronics manufacturing is happening, from there it is turning into e-waste, and e-waste is either recycled or repaired and refurbished. If it is recycled, it is reducing the greenhouse gas, and if it's repaired and refurbished, sometimes parts recycling are there. Not everything is going to waste, so a part of it is recycled, and that helps in reducing the energy consumption, and that's how it has a positive impact on climate change. So what are the solutions? Circular economy, circular economy, circular economy. That's the way forward. So we have to focus on circular economy, work on circular economic attitude, bring into our and this is the e-waste microfactories. This was developed by Dr. Veena Sahajwala. She is a material scientist from Indian born, currently in Australia. So this is a very beautiful concept she has invented. So I don't have much time to cover the whole of my factories, but this is a very good approach, and this is certainly the future. So combining urban mining, integrated e-waste facility, and supply chain, combine it together in a certain proportion, you can achieve circular economy. Repair and refurbish cafe. This thing is almost out of fashion now. We don't look forward to repairing, but still we want to repair. So repair cafes, renew them in the way the waste is doing. It's our concept. They're doing it in their way. Partner with the informal sector. Don't just stay disconnected with them. So be interactive, be synergistic with them. Some of the cases are also working in Bhubaneswar and as well as in Bangalore. So partner with them. Green electronics. This is another approach to reduce the hazardous material in the increase awareness, like collection days, electronic recycling events. Such like we are celebrating World Environment Day, we can celebrate the e-waste day as well. So in e-waste song, I took a small project to develop awareness on e-waste. So I did it in 2018. So this is the e-waste. Such more songs and other small videos can be made to make people aware. And finally, the SDGs, the Sustainable Development Goals, as it was saying, the UN's decade, as it was mentioned by Dr. Sir. So we have to work towards the SDGs, to achieving these SDGs, and certainly climate action is one of them. So, way to sustainability: partner with the informal sector, more increase awareness, implementation of rules, circular economy framework, and work towards the SDGs. So, my co-authors and collaborators and the universities they are from, and I am thankful IIT NSS Unit for inviting me to deliver this particular presentation, and Commonwealth Scholarship for funding me, Aston University, Jadavpur University, of course. So, and I think to myself, what a wonderful world. Thank you. And before I end, I would like to mention one simple thing, and that is the pandemic has taught us how much sustainability and circular economy is important. The several premier institutes in our country is bringing sustainability and circular economy. It is really important for us to look into that sector and develop tailored courses, and a dynamic institute such as RCIIT could be a pioneer in that sector in West Bengal to develop such tailored courses. I mean, now it's work from home. It could be done in different forms. That's my opinion. And thank you.
for sharing your valuable insights towards sustainable